So today we're talking about three-dimensional figures, and specifically we're talking about cross-sections. This is when you cut a 3D figure with a plane, and you get a two-dimensional shape. So here's some different pictures. The first one shows us cutting a square along the middle. The resulting two-dimensional shape is this square on the inside. If I cut a square diagonally, it can give, or a cube diagonally, sorry, it can give me a rectangle. And this one, if I cut it in the corner, it can give me a triangle as my result. So depending on how I cut it, it'll give me different shapes. So down below, I want to see which of these 6 shapes I can cut to make a circular cross-section. So which of these, if I cut them in any way, can give me a circle? Is there any way I can cut a cylinder, which is like a can? Can I cut that to get a circle? Yeah, I would cut it straight through the middle horizontally. Can I cut a cube and get a circle? No. What about a cone? Yep. A sphere? And a triangular prism? Yep. A right pyramid. So I have a square base and then triangle sides pointing up to the top. No. So, just down below I have the different ways I can cut an object. I can cut it vertically, angled, or horizontally. So cross-sections can be a single point or a two-dimensional shape. So up here it's touching at the very top, which is just a point. Down here it is touching and making that square in the middle. So I want to take a look at these cross-sections and see what shapes I can get. So if I cut this cone vertically, what shape is it giving me in the middle? It's giving us a triangle. Which I can see right here. What shape am I getting from this triangular prism right here if I cut it horizontally? This one is a rectangle. Then these two want me to draw a cross-section that is parallel to the base and then say what the shape is. So if I was cutting it, it'd be something kind of like this. What shape would I get from cutting it like that? Circle. So I just need to draw the cross-section and say it's a circle. Okay. This next one wants me to draw a cross-section of the prism that's parallel to the bases. What's the shape of the cross-section? So parallel to the bases is the two sides that look the same, which are these hexagons. So if I cut it like this, what shape would I get? So that's a vertical cut. This one would give me hexagons. next page, I have 2 more that want me to say what shape would be formed. It wants it to be perpendicular to the base and goes through the vertex, so through this point. So I'm cutting up and down. What shape would that give me? Triangle. Okay. Same original figure, it wants it parallel to the base, so I'm cutting it horizontally. That one would give me a square. Okay, so the next one wants me to circle all of the shapes that are possible cross-sections of a cone. Remember, think of a cone like an ice cream cone. Which of these can I get if I cut a cone? So I'm going to sketch out a cone up above. I can get a triangle, circle. I can't get a trapezoid because the cone is curved. There's 2 more I can get, and these ones are a little bit trickier. I can get a parabola, so that's where if I go diagonally down the cone, I will get it. And another one I can get is an ellipse, which is a different kind of diagonal, but also going diagonally through the cone. Okay, so this one says if AB equals 5 meters, BC equals 4 meters, and CG equals 12 meters, identify the shape of the cross-section of BCHE and find its perimeter. So I'm going to highlight BCHE so I can see it a little bit better. It's this one right here. So what shape is that? Rectangle. And then I want to go ahead and label everything the problem told me. I have that AB is 5, BC is 4, CG is 12. So the only thing I actually have on this rectangle right now is one of the side lengths. In order to find the perimeter, I need both of the side lengths. So I know that this rectangular prism is 5 meters tall. I can move this 5 to GH because it should be the same height all the way around. And then if I look, I have a right triangle right here in this corner. So I can use the Pythagorean theorem. I'm going to label HC as my C length because that's the hypotenuse of the triangle. And I'm going to go ahead and plug into the Pythagorean theorem, which remember is a squared plus b squared equals c squared. So I get 25 plus 144 equals c squared. Adding those together, I get 169. Then I want to go ahead and take the square root of both sides. And so I get 13 is this side length right here. So if I go ahead and draw out this rectangle, I know that this side length was 4 because it gave it to me, and I know that this side length is 13 because I just found it. Opposite sides are congruent. So I know that EH is congruent to BC, and EB is congruent to HC. And then I just want to add those numbers all up together to get my perimeter. Which gets us 34 meters. The next one wants me to find the area in terms of pi of the cross-section formed by the plane passing through the center of a sphere with a radius of 6 centimeters. What shape do I get from cutting a sphere? Circle. So I should be using the area of a circle formula here. So I have pi r times my radius, radius squared. It's important to remember spheres cross-sections will always be circles no matter what. It wants me to leave my answer in terms of pi, so I just need to square that 6, which is 36, and then I leave the pi, centimeters squared. Okay, so then I just have a few statements at the end. I want to select all the true statements about cross-sections of 3D figures. A circle is a possible cross-section of a pyramid. True or false? False. So I'm not going to check that one. All cross-sections parallel to the base of the prism are congruent to the base. So prisms are like things like cubes and triangular prisms, those things. True. Okay. All cross sections parallel to the base of a pyramid are congruent to a pyramid, or to the base. So, if I think back to this pyramid right up here, is that square that we cut out, is it going to be the same size as the square at the bottom? No. It's going to be similar, so it's still a square, but it's not the same size. A square is the only possible cross-section shape of a cube. And that one's actually false, because I can cut a cube. Let me draw my cube really quick. I can cut a cube to give me a triangle, remember. That one's false. And then the last one, a rectangle is the only possible shape of a cross-section formed by a plane perpendicular to the base of a cylinder. So if I cut a can up and down, is a rectangle the only shape I can get? This one is true. Because if I'm cutting it up and down, it will give me rectangles of different sizes.